Alright, this is 6-1, Lesson 1, Domain of a Rational. Now, a couple things we need to get used to. First off, the concept of domain. Domain is everything that can go in. So, domain can go into the function. So in other words, if I put in a value of x and it works, it's in the domain. If I look at my second example right here, if I plugged in positive 1, x was 1, right? So 1 minus 1 would be 0. We can never have 0 on the bottom of a fraction. So when we talk about the domain, we're taking things out, specifically for rationals, we're taking things out that make the bottom 0. So, in general, your domain is always going to start as all real numbers. Okay? And so, on this first one, is there anything that can make the bottom 0? Any value of x you can plug in? No. So I would say the domain is a set, that's what the squiggly line is, a set of x's such that, the vertical line means such that, x is a real number. Now, that's one way of saying real numbers. You can also use this symbol for all real numbers. It's an R with capital R with an extra line, a bold R in other words. So the squiggly brackets means we have a set, so we have a list of numbers that look like an x, whatever the x can be, and the x is a real number. Now on the second one, we already noticed that the bottom, all right, if we plug in 0, if x equals if x equals 1, it blows up. The bottom becomes 0. So we need to make sure that our domain does not include it. So how would we say that? Well, we just say that literally. So the domain is a set of x's such that x does not equal 1. See? Quite simple. And then for our last one, oh, well, this is something we should probably factor. So if I do my list, what multiplies to be 15 and adds to be 2, well, negative 15 and negative 2, I think that's going to be negative 5 and positive 3. So x plus 3, x minus 5. They multiply to be negative 15, they add to be negative 2. Well, what makes this one equal to 0? What makes this one equal to 0? So those are the two numbers that we cannot have. In other words, our domain is going to be a set of x's such that x does not equal negative 3 or 5. Alright, pretty much that's it for the first lesson.